9 and 8.3. I haven't read it. I need to read it. Transmission fluid is leaking out of the vehicle at a rate of R of T, and they give you the formula, ounces per hour, where T is the number of hours. How many ounces of fluid leak from the vehicle between T equals 0 and T equals 3? So generally speaking, what do we know we're doing on this problem? We're talking about how many ounces leak from the vehicle. We're trying to integrate the rate. And the rate, I mean, you can start off as R of T, right? What's the interval? 0 to 3. Now, the deal is they actually give us what R of T is, though, don't they? So really what we're doing is we're integrating from 0 to 3, negative 3 times T minus 2 dt. Now, okay, I can't say that I've looked at her answer key today to know how she did it. Okay? Just because she did it one way doesn't mean it's the only way that works. Okay? So options when we go to integrate this. There's one of two places we can start. Did you guys have a thought of where you wanted to start, or?
We could distribute.
Okay. One option would be to distribute the negative 3. And then you're integrating negative 3t plus 6. You can do the u, but you don't need the u. Okay. My other option is negative 3 is a constant that's being multiplied. The other option, if you don't want that negative 3 in there, is you could move it out in front. And you just have to multiply everything by negative 3. In mine, I distributed. Is that what she did, maybe?
Hers went straight from that to negative 3 halves x times x minus 4.
Evaluated at 0 to 3.
Yeah.
I got nothing. Okay. Let's distribute. I'm going to distribute. So that means it's going to be negative 3t plus 6 dt. Are we okay with that option? Okay. Because I have no idea what you just read. I got nothing of how that makes sense. So, okay. So with that in mind, you've got two separate terms being added. So let's integrate. What is the integral of negative 3t? Yeah, you're going to add 1 to the power. It becomes t squared. Divide by that new power, which makes it negative 3 halves. Plus the integral of 6. 6t. 6 constant becomes a t. Evaluated from 0 to 3. Okay, so if I plug in here, plug in the 3, negative 3 halves times 3 squared plus 6 times 3. Officially it's that, and then minus, now here's my deal. I know some people they'll get in a bad habit of just skipping plugging 0 in. But as soon as you skip plugging 0 in, there's actually going to be something that's going to matter. So I always ask that you look at it. In this case, we'd end up with 0 squared times negative 3 halves, so that would be 0. And 6 times 0 would be 0. So it truly doesn't matter, does it? But don't just skip that, oh, it's 0, it's not going to mean anything. Because there are certain times, like for instance, if 0 is in the exponent, something raised to 0 has a value of 1, not 0. Okay? And we're evaluating from, what am I doing? We just evaluated from 0 to 3. I'm going to evaluate a second time. Okay, so let's do some math. 3 squared is 9. 9 times 3. So negative 27 halves, if you will. Plus 18. If I'm truly doing this without a calculator, I'm going to make this a common denominator and say negative 27 halves plus 36 halves. Negative 27 plus 36 is
Positive measures. Wait, oh yeah, positive.
Positive 9 halves. And positive 9 halves is 9 halves or 4.5. And the question was how many ounces of fluid leak from the vehicle? And so that is 4.5 ounces of fluid. Okay, is that solving better?
Yeah.
Okay. The difference between me and the answer key is I'm not going to skip the bazillion steps that she does some crazy skipping at times. There have been times where I can't figure out where she goes because the skipping she does. Okay, that was number 9. And
Part of 13.
we need to talk about some 13. Are there specific pieces or just anything or?
The definitely.
Because I'm debating how much of I need to do versus, are there pieces I can skip?
Not A.
Are you guys okay with A?
Yeah.
Okay, hold on. Let me pause for a moment, just because I haven't read this question as recently as you guys. The student council elections were held at school between 7 a.m. and 3 p.m. Students deposited their ballots in a special box located in the media center. The number of entries in the box, T hours after 7 a.m. is modeled by a differentiable function, E of T, for 0 to 8. Table shows the number of ballots at various times T during the day. Okay, and then for A, at what rate are the ballots being deposited into a box at noon? So when T equals 5, show your computations. If we're being asked to find the rate, you're being asked to find like the slope, right? Okay, so, or you could think average rate of change. And so, I have it written out as E of 6 minus E of 5. So using the points at 6 and 5. Okay. Now, B was the question that we're going to talk about here. Using a trapezoidal sum with 4 subintervals, approximate the value of the expression below. Then using the correct units and context of the scenario, explain the meaning of the expression. So we're doing 1/8 of the integral from 0 to 8 of E of t dt. Okay. Now, with this in mind, first of all, there's going to be a 1/8 out front, yes? Because they give us the 1/8. So I know I'm multiplying everything by an 8. From there, okay, it's the integral from 0 to 8, which is that whole chart up above. You have that chart in front of you. Trapezoidal sum. Well, as I start looking at this trapezoidal sum, we're going to have the 1/2. What about the height? They're all different, yes? Or I say height in terms of the trapezoid formula, 1/2 times height times b1 plus b2. But recognizing on trapezoidal sum here, the height is the distance between the two. So it's the width, which we have widths of what? 3, 2, 1, 2. So can we do the shortcut we just did yesterday? No. You're going to have to do each of these individually. Now, and again, I don't know exactly what she wrote. What is in common of the trapezoid? They're all going to have the 1/2, yes? Because that's part of the formula. Could you go ahead and put that 1/2 out front? You can if you want. Or would it be better if we just put the 1/2 with each trapezoid formula?
I think I do with each trapezoid.
Okay. And that's what my notes have, but, just, okay. So 1/2, if we look at the first interval from 0 to 3 is a width of 3. And then base 1 plus base 2, well, the interval 0 to 3 is going to have heights of 0 and 120. So 0 plus 120. That's our first trapezoid. Plus, and it did say 4 subintervals. So that's what we're doing here. Next one. 1/2 The width of the interval this time from 3 to 5 is 2. Base 1 plus base 2 is going to be your 120 plus 382. Keep going. We've got 2 more to do. I'm just going to bring it down below because I'm going to run out of room. 1/2 times the next width. What are we doing? 5 to 6. So width of 1. Base 1 plus base 2. 382 plus 578. Plus, and one more, 1/2. A width this time from 6 to 8 of 2. And then base 1 plus base 2. 578 plus 694. Okay. At that point, that definitely becomes a calculator problem. Okay. I know I'm going to have the 1/8 out front. 0 plus 120 times 3, 360 divided by 2 is 180. Half of 2 is 1, so it's just 120 plus 382, which is 502. I don't know. Tate's my mental math person. I don't think he's feeling it today. 382 and 578 is something, and then half of it I have down as 480. Half of 2 is 1, so then you're just adding 578 and 694 and getting 1272. Add those up, and you're doing 1/8 of it. So you're doing 1/8 of 2,434 according to my notes, which is 304.25. Now, note, it did specifically say then, using correct units in context of scenario, explain the meaning. So you don't get to just put an answer. You don't get to just put a basic label. We need an explanation. What is this 304.25?
The average number of ballots in the box from 0 to 8 hours.
Okay. So average number of ballots in the box. Now, 0 to 8 hours, or that could also be said as between 7 a.m. to 3 p.m. Okay. So always good if you can to try and put it in terms of the like 7 to 3 type thing. Okay. I'm not saying you wouldn't get credit if you did the 0 to 8, but because it's true, you know, both things are true. I don't need to write that part out, do I? Okay. Do I need to keep going? Should I talk about C? What do we have here? At 3 p.m., the Student Council Election Committee begins to count the ballots at a rate modeled by the function. So they have a rate function that they're giving us, so that's a good thing. P of T is ballots per hour for 8 to 12. According to the model, how many ballots remain to be counted by 6 p.m.? So when T is 11. Okay. So they want to know about how many ballots remain to be counted, right? So you have so as we talk about C, okay, P of T is the function that gives the rate for counting the ballots, right? So it talks about how many ballots are counted from 8 to 12. Okay, so from 3 to what, 7? Okay. Now, with this in mind, if we talk about the integral of P of t here, okay, that's talking about how many ballots are counted. We're being asked for how many are counted by 6. So what interval am I doing here? If it's how many are counted by 6, which is when t is 11, not 0 to 11,
8 to 11.
because when do they start counting them? At 3 o'clock when the elections end, right? So from 8 to 11. Now the question is, how many ballots remain to be counted? Well, if we're talking that, this gives us the evaluation of how many have been counted. How are we going to figure out how many remain to be counted? Yeah. You have to look at the fact how many total ballots were submitted. At 3 p.m. there were 694 ballots submitted, right? So you're going to have the 694 ballots, taking off what's counted between 3 and 6. And that's going to result in how many remain to be counted. Okay, does that make sense there? Okay. This one is definitely a calculator one. That would not be an, so this would be definitely be doing 694 minus the integral from 8 to 11 of that formula. 250 over 1 plus 0.6t minus 5 quantity squared dt. Okay, so 190.0030, or even just 0.003, so that is about 190 ballots, right? Okay. Now, did you guys figure out what they did on D? You had D circled? Okay. Because this goes back to, I don't know, I'm trying to think of when we talked about this idea, but okay, so D, the election committee tallied ballots from 3 to 7. According to the model P of t from part C above, at what time from 8 to 12 were the ballots being counted at the fastest rate? And justify your answer. Okay, so if we're looking for the fastest rate is a what? We're looking for the fastest rate. In terms of math, we're looking for the max. Okay? When is that function at its max? Now, with that in mind, okay, and I don't know exactly, okay, what she showed versus didn't show. How do we find a max? This goes back to first semester. Set what equal to 0? Okay, so in order to do a max, we're going to be looking for when does P of t equal 0. Now, that means I'm looking for when does this function equal 0. Okay, because when a derivative equals 0, that's when there's a max or a min. This isn't a do it by hand type thing. My suggestion is a graph. Okay, I would say graph the derivative and see when does it equal 0. Okay, so if you graph that, what are we graphing? 250 over 1 plus 0.6x minus 5 quantity squared. Now, keep in mind, I graphed the wrong thing. What did I just graph? Were you guys listening to me? What did I type in? Did I type in the derivative? No, I typed in P of t.
Oh, that's what I just did.
Okay. And as I'm looking at this, I'm like, why am I not getting anything in the interval? Because here's the other thing, is we have to get something, we have to be talking on this interval of 8 to 12. Okay? So I was like, that didn't give me what I was expecting it to give me. Here's the deal, guys. I need the derivative. Now, you could graph a derivative on the calculator. Have we done it? I don't know. Have we done it recently? Definitely not. But here's the deal. If we go back into y equals, and what we can do is you can use your Alpha F2 or your math menu, go to derivative, so in deriv, put that there. We can put that we're doing the derivative right into y2. So that's d dx. You can type in the equation. In all honesty, since my equation is still typed in y1, could I just type y1 there? I can. So I can use y1 in place of the equation. And then when it says x equals a number, we don't have a number, so you just put x equals x. Okay? I'm going to turn my y1 graph off. And now I'm going to graph y2. Okay. Well, now I at least have something crossing the x-axis, so I have a derivative equaling 0. One thing I will say, we are specifically caring about the interval up to 12, right? So I'm going to change my window. I'm going to make it 0 to 12 for my x's. Oh my gosh, this is graphing so slowly. Okay. And we have something right there between 8 and 9. Okay. How do we find that exact number?
0.
Find your 0, second calc 0. For your left bound, you need to get over there somewhere. Okay, so the first time my cursor appeared, I'm below the graph. So I need to go back above it. So I'm going to just go left one. I'm at 8.27. I'm up at 10, so that'll go for my left bound. The right bound, now I'm at a negative y value, so I can hit enter there, and I can hit enter again. I have a 0 at 8.3 repeating. Okay? So, what do we know? 8.3 repeating. Now, here's the deal, guys. Okay? With this in mind, when we talk about something like this, one where the ballots being counted at the fastest rate, officially, we check any critical points. This is what we just found with the 8.3 repeating. This is a critical point. And we also have to, if we're on a set interval, we have to check endpoints. Okay? So, officially, what you'll see is we have to check the endpoint of 8 when we start counting, 12 when we'll finish counting, and that critical point of 8.3333. Okay? Now, that find the points we need to test, you're plugging them into P. Okay? Because we're not plugging them into the derivative, because like 8.3, that's just going to give me 0. You're plugging them into the original, the rate function. So the function that finds how many ballots are being counted. Okay? I'm going to say we did this one by graph. Did you get one of the values?
8 is 240.
All right, it's 385.
8.33 is 249.999.
So that could officially be written as 250 then, yes?
So,
I know, I had to think. I was like, wait, what did you say, 999? Was it even 9s past that, I assume? And then 12.
42.808.
Okay, guys. The question was, at what time were the ballots being counted at the fastest rate? When t is 8.3 repeating? Now, so, you could write out at t equals 8.333, ballots were counted the fastest. About what time is that? In terms of hours and minutes.
8 hours and 15 minutes.
Mm-hmm. So what time does 8 represent?
0.
what is this one?
So 0 to 11, 0 to 8 was 7 a.m. to 3 p.m. 8 to 12 is 3 p.m. to 7 p.m. 8.3 is
3:15.
not 3:15.
I'm getting it.
That would be 8.25.
3:20.
Because what's a third of an hour, right? So that would be at 3:20 p.m. Now, could you also just say at t equals 8.33? You can, yes.
Yeah.
I'm just, it's good to be able to make those connections. Sometimes you need to be able to say those. Okay. Are we good there? Okay.
Yeah.
We need to talk some notes. We do.